SA 530 Audit Sampling. First, sampling risk. Sampling risk is a risk that the auditor's conclusion based on a sample may be different from the conclusion if the entire population were subjected to the same audit procedure. Sampling risk can lead to two types of erroneous conclusions. Type number one error, all good when it is not. Type 2 error, all bad when it is not. Type 1 error, all good when it is not. That is over reliance on controls. In the case of test of controls, that controls are more effective than they actually are. Incorrect acceptance. In case of test of details, that a material misstatement does not exist even when in fact it does. Reduces effectiveness of audit. The auditor is primarily concerned with this type of erroneous conclusion because it affects effectiveness. Audit effectiveness and is more likely to lead an inappropriate audit opinion. Type 2 error, all bad when it is not. Under reliance of controls. In case of test of controls, that controls are ineffective, but in reality, they are effective. Incorrect rejection. In case of test of details, that material misstatements exist when in fact it doesn't. Reduces efficiency of audit. This type of erroneous conclusion affects audit efficiency as it would usually lead to additional work to establish that initial conclusions were incorrect. Initial conclusions were incorrect. Next, non-sampling risk. Chances that auditors reaches inappropriate conclusions because of reasons given below. Inappropriate procedures, failure to recognize misstatement or deviation, misinterpretation of audit evidence. Next, sampling process. First, sample designing. It is the preliminary sampling step. Suppose we have to examine occurrence of sales. We have to determine our objective, catch fake sales, audit procedures, match with dispatch report, etc. are decided in this step. Second, sample size. After analysis of various factors, it was set a 200 units from each of east, west, south, north area. So total 200 into 4, 800 from population of 5,000. Third one, selection of items for testing. Sampling selection method. Stratified random sampling. The method of sampling is stratified random sampling. Fourth one, performing audit procedures. Inspection of documents and inquiry from sales executive. Fifth one, nature and cause of deviation and misstatements. Intentional or unintentional, manual or automated. Next, projecting misstatements. If there are fake sales in sample, then how much in the whole population? We need to estimate it. Seventh one, evaluating the results of audit sampling and taking action. Whether misstatements are within tolerable limit, whether further audit procedures should be applied, shall be decided here. Step 1, sample designing. Define population and its characteristics, that is all sales transactions. Next, stratification, area-wise bifurcation in east, west, north, south. Consider purpose, examining sales transactions, whether any of the transaction is fake. Consider audit procedures, check sales transaction from customer order, gate pass, transporter report, delivery memo, confirmation, inquiry from sales executive, and visit go down. Next, nature of audit evidence, documentary, oral, or visual. What constitute misstatement? If essential documents of transactions are missing, it can be misstatement. Different dates in documents is fine if it's within 3 to 4 days of sales transactions. Second one, step 2, sample size. Sample size. Sample size is inversely proportional to sample risk. Auditors decide audit risk at planning stage, then determine detection risk and sampling risk. Now sample size is determined in such a manner that audit risk is reduced to acceptable low level, that is pre-decided. Statistical formula or professional judgment is used to determine sample size. See following factors affecting sample size. Important points. Audit sampling is used both in case of test of controls and test of details. Test of controls error is called as deviation. Test of details error is called as misstatement. Risk of material misstatement is directly proportional to sample size. What do you mean by performance materiality? Tolerable level of misstatement. In case of monetary unit sampling, population is directly proportional to sample size, which is based on materiality. Factors affecting sample size. First factor affecting sample size is increase in assessed risk of material misstatements. Second one, decrease in other substantive procedures. Third one, increase in expected misstatements. Fourth one, stratification not possible. Fifth one, increase in desired level of assurance. Next, decrease in tolerable misstatements. Next, increase in population. So these are the factors which affect sample size. Next, what is the difference between risk of material misstatements and expected deviation or misstatement? Timing. Risk of material misstatements should be checked at the time of initial stage, whereas expected deviation or misstatements should be checked just before sampling. What is the basis for determining risk of material misstatements? Information collected. Next, what is the basis for expected deviation or misstatement? Some testing before determining sampling. Decisions by comparison. If expected deviation is greater than tolerable deviation, then cancel test of controls, focus on substantive procedures. If expected misstatement is greater than tolerable misstatements, then cancel sampling for test of details, focus on 100% checking. Effect of population size on sample size. Present population size is big. For example, 10,000 labor to 12,000 labor, 5,500 sample items to 505 sample items. If there is increase in population size, there will be a negligible effect on sample size. Efficiency will increase. If present population size is small, from 10 labor to 500 labor, 4 sample items to 100 sample items, if there is increase in population size, sample size increases and there will be less efficient. But if there is proportionate increase in materiality or tolerable misstatement level, then increase will be compensated, will get compensated. Next, step number 3, selection of items for testing. Approaches to sample selection. There are two approaches, statistical, non-statistical. Important points. Sample should represent representative of population. The sample should be representative of the population. These approaches are not about sample size, but the way the items are selected as sample. Advantage of statistical sampling. First one, better description of large mass of data than complete examination of all data. Sample size does not increase in proportion to increase in size of population. Means to estimate minimum sample size with specific risk and precision. More objective and defensible. Collected risk, calculated risk. So these are the benefits of statistical sampling. Sample selection method. Method should be such that sample should represent population. Following are the methods: statistical sampling, simple random sampling, stratified random sampling, interval based or systematic sampling, cluster sampling, monetary unit sampling. Next, non statistical or judgment based sampling, haphazard sampling selection, haphazard selection, block selection. First one, random sampling. It is based on statistical techniques. Random sampling, all items in the population or strata have equal chance of selection. Then we may be we may use random number table, random between Excel function or anything like this to select sample. Types of random sampling. Simple random. It is suitable for homogeneous, that means same population, no division of population. Every unit has unknown or equal chance of selection. Random number table, picking numbers from drum, etc. Stratified random, suitable for heterogeneous population, that means not same population. Divide population in group called strata. Each stratum is treated as a separate population and random sampling is done. Different percentage selection can be done for different strata. Recall trade receivables example. Next, interval based or systematic sampling. Constant interval is used for selection. First unit is selected randomly within first interval. Then constant interval is used to select other units in sample. Interval can be in number or monetary value. For example, population is 5,000, sample size is 1,000. Interval 5,000 by 1,000, 5. Interval in number. First interval 1, 6, 11, 16. Next 4, 9, 14, 19. For example of interval in monetary amounts, see monetary unit sampling. Problem. If population is structured in particular manner and intervals are similar to these structures, similar type of items will get selected, not representing whole population. The solution is to resolve above. We can have random starts after few selections. Next, cluster sampling. Step 1. Divide population into groups called clusters. Example cluster of 10, 20, 30, etc. Step 2. Randomly select clusters from all the clusters. Next, step number 3. Either select all items in the cluster or again apply random sampling to select units from the cluster. While applying random sampling within cluster, use simple random sampling or unrestricted sampling and stratified random sampling. This method is cost effective, but results are less effective as compared to simple random sampling. Monetary unit sampling or value weighted assets, value weighted selection. Monetary amounts are used for sample size, selection method, evaluation of results. Total sales, for example, total sales are 20 lakhs. Sample size is 5. Monetary interval will be 20 lakhs divided by 5, that is 4 lakhs. Starting point randomly between 1 to 4 lakhs. Say 620. Selection points will be 620, 4 lakhs 620, 8 lakhs 620, 12 lakhs 620. This is monetary unit sampling or value weighted selection. Monetary unit sampling can be used with interval unit sampling. Next, haphazard selection, that is non-statistical sampling. Here, there is no structured technique or pattern. Use of personal judgment will be done. Avoid bias or predictability. All items should have chance of selection. It is a non-statistical technique. Block selection. Block selection is also a non-statistical technique, not selecting single item in selection, but selecting group of consecutive items, say 20 or 30 or 40. Starting point can be as per auditor's preference for each block selection. Sometimes it may be appropriate, but majority times it won't be suitable because items with similar characteristics will get selected. Step number 4. Performing audit procedures. Shall perform selected audit procedure for each item selected. If audit procedure is not applicable on any item, replace it with a new item and perform procedure on it. Example, cancel check gets selected while auditing payments. If auditor is unable to apply audit procedure on selected items, perform alternative procedure. If there is no suitable alternative, then it is a deviation or misstatement. Example, unable to apply audit procedure on data because documents are lost or no reply received for positive confirmation request. Checking subsequent receipts is alternative audit procedure. Next, step number 5. Nature and cause of deviation and misstatement. Investigate. Investigate nature or cause of any deviation or misstatement. Nature. Rarely auditor may come across anomaly. Anomaly means rare misstatement. Perform additional procedure to ensure that it is not representing population. Common feature, type of transaction, location, product line, period of time. Identify all items with common features and extend audit procedures. Cause. Cause may be unintentional or intentional. Effect. Consider possible effect on defined audit objective and effect on other areas along with example branch A and branch B may be selected and effect on reliability of employees or systems. Step number 6. Projecting deviation or misstatement. For test of controls, not necessary to do explicit projection generally. Sample rate of deviation equals to projected rate of deviation. For test of details, shall project misstatements found in sample to population to obtain broad view of scale of misstatements not sufficient to determine amount to be accounted. Exclude effect of anomaly while doing projections. While making final conclusion, if it is not corrected, then anomaly needs to be considered along with projected non-anomalous misstatement while evaluating sampling result. Step number 7, evaluation of sampling results. Projected levels. If in case of test of controls, controls are reliable and low risk of material misstatements. In case of test of details, no material misstatement. Then it is a reasonable basis for conclusions. Expected levels. In case of test of controls, controls are not reliable and high risk of material misstatements unless there is further audit evidence to prove opposite. In case of test of details, material misstatements unless there is further audit evidence to prove opposite. Next, in case of tolerable levels, test of controls. Test of controls. Controls are not reliable and high risk of material misstatements exist. In case of test of details, material misstatements exist. Reasonable basis for conclusion. In case of expected levels, sampling alone does not provide a reasonable basis. Unacceptable sampling risk that actuals are more than tolerable limits. Request management to investigate misstatements and potential for further misstatement. Modify nature, timing, and extent of further audit procedure in case of test of controls or test of details. If there is anomalous misstatements, consider it along with projected misstatement and then compare with tolerable misstatement. If its close or more than tolerable, then sampling is not providing a reasonable basis for conclusions. Here levels means rate of deviation or misstatement. Anomaly means rare misstatement. Tolerable level means maximum misstatements or deviations allowed level.